3.2, law of cosines. So again, how do we tell the difference between law of sines, law of cosines? For law of sines, if there's two angles, or if it's a donkey, then it's law of sines. For law of cosines, if there's two sides, so we have side, 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 or side, angle, side. So side, 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 angle, side. This is law of cosines. Notice how there are three different equations. In each one of these equations, you could also rewrite it. So we could do this because we are smart individuals and we could algebraically figure this out for ourselves. However, this is also the just alternative. So what if we have first three different sides? You could really start with any one of these, but a lot of times it's always easiest to look for the largest angle. So the largest angle is always across from my largest side, so this right here. So I want to look for B. So I'm going to use this equation right here. So cosine of B, we're going to have to figure out what that is. It's going to be a squared plus b, or c squared minus b squared. So we're using this formula right here. And then we're going to do the inverse cosine of that. Now, when you type this in, I want your exact answer. So inverse cosine of that whole equation would give me that angle right there is 116.80 degrees. Now, at this point, you could definitely go through and figure out A and C in that same manner. However, because we already know the law of sines, we can also use law of sines. And personally, I feel like law of sines is a little bit easier. So now that I have my angle B, I can use that ratio right there. And I can multiply that 14 over and take the inverse sine of it. So it looks something like this. Make sure when you type this in, you close this parenthesis. Again, I want you to have the most articulated answer. So this would be 41.12 degrees. That's our angle C. So now that we have two of the three angles, we can go break it down to the OG 180 and minus our two angles. We get our last but not least, angle A is 22.08. So now we have example 2. Now, first thing I would do is, because again, we have two sides, so this is going to be using law of cosines first. I want to figure out my side length first. So I'm looking for this A. So now I'm going to use this equation. A squared is equal to this whole equation. So if I plug that in there, and we're going to take the square root of that because that's how you get A by itself, we get that A is equal to 5.41. So now here again, we want to use this side to look for a law of sines, or using our law of sines. So now that we have our A and A, that's going to be our ratio. So if we want to figure out, I'm going to figure out B next, and then we do our inverse, we get that B is going to be equal to 44.67. Now here again, we want to check to see if this is a special case. Now you don't have to draw out this picture each time, but just so you know how we're getting this angle is 44.7. That means this reference angle is 44.67. So first we want to figure out what this angle could be. So this angle right here, we want to see if there's two answers for this. And we would get 135.33. So again, our third angle that we already have is 25. So if we add 25, is that greater than 180? No. Since this is not greater than 180, we're going to have two answers. So angle B can be 44.67, or it can be 135.33. Now again, bringing back the OG, A squared plus, all the angles add up to 180. So angle C, if I do 180 minus 44.7 minus 25, we're going to get our 110. Could also be angle C, sorry for my degrees, or I could do 180 minus 25 minus 135 and get my other angle could be 19.67 degrees. So there would be my three different missing pieces with that law of cosines. Right now you should pause and read example 3 first. So again, if you wanted to, sometimes it's easier for people, instead of doing this, have A, B, C, relabel them. That means this is little a, this is little b, and this is little c. So we have two sides with that included angle. So this is going to be our law of cosines. So we are looking for a little a. That's what we want to find. So we want to use that first equation. A squared equals b squared plus c squared minus 2bc cosine a. And we would take the square root of that to get A by itself, and we get 42.3 feet distance from pitcher's mound to first base. For now, I want you to pause the video and read this one. So this one, essentially what we're looking for is the bearings from B to C. So we're looking for angle B. So if we're looking for angle B, we're going to use the formula for cosine B right here, this one, to solve for angle B. And if you do the inverse to that, you would get that this angle is 166.15 degrees. However, that's not how we say bearings. We're smarter than that. So if this is over 90 degrees, we first have to subtract 90 from this because we want to figure out which direction we are going in, which would give us 76.15 degrees. And to help you, you could always draw a little mark right here. What are the bearings? Well, you're going north and you're going east. So north, 76.15 degrees east would be the bearings for that. And last but not least, we have an area formula. Dun, dun, dun. So what if we know all the sides of a triangle, but we don't, or we want to find the area? The formula we use for our oblique triangles had sine, so we need to have an angle for this one. We don't have an angle for this. So if we want to find the area of this right here, we use this formula. So first we have to figure out what S is equal to because we need S for all these locations. So S is going to be equal to add the three sides up and divide by 2. So 168 divided by 2, which will give me 84. So this is what S is equal to. So this is our S. So now we can use this equation right here. I would highly suggest to always write it out because you don't want to make a dumb, stupid mistake. So if you put this into your calculator, you get 100 or 1,131.89. In this case, we're talking about meters, so meters squared. And bang, bada boom. That's all we got for you today. Have a wonderful day.